So we will continue our discussion. We discussed about the dikes and sills yesterday, and we said that they are intrusions. However, they are thin intrusions in the rocks, and as a result, they sometimes they have some effect on the landscape of or tectonic landscape. Similarly, the veins. However, the bigger influencer on the landscape and landforms are the uh, intrusive igneous rocks, especially we called yesterday the monodocs and the bathylates, lacolates, and stalks. Tectonic landscapes can also be created by earthquakes. They can be created as a result of faults and faulting, and you guys know what faults and faulting are. The rift valleys, and we have the ground displacements and folding. We have faults, and as you guys remember, a fault is a break in the crust where we have the earthquake, and then there is a break, there is a rupture, जिसको आप उर्दू में शिगाफ कहते हैं. So that is basically the reason behind the faulting, and as a result of this earthquake, the tectonic take place. We normally call this type of tectonics that take place in your lifetime as neotectonics. Just like if you want to read more about it, just read the 2005 earthquake in Kashmir. You can read an article about that, and you will see that how uh, earthquakes and how faulting can deform an area. Similarly, faulting can also initiate landslide, and that landslide can block a river, and that river blockage can result in the formation of a lake. So geomorphological features are faults, and faults usually occur along the plate boundaries where the plates motion compresses, it pulls, and moves away from each other. We have a fault, a larger fault that is present in this area, and you can see that there is a focus and there was an earthquake, and as a result of this earthquake, we call this point as a focus, and exactly above that point on the surface, we call that place as epicenter. So now you can see that there is a highway that is passing from this area, and then there is a fault trace that is present. And as a result of this fault trace, there is some disturbance, and as a result of this disturbance, the morphology of the Earth is changed. So we can say that the faulting greatly influenced the overall morphology of the area. Especially the mountainous areas are highly influenced by these type of tectonic changes. Then we have the strike slip faults. You can see that here we have a strike slip fault that is present, and you remember in strike slip fault there is no upward downward movement, but there is relative movement of two parts away from each other. And you can see that in this fault we have two blocks that are moving away from each other, and as a result of that, sometime when there are streams that are continuously moving across the fault, those streams or those channels are disturbed as a result of the faulting. Or they can also form the plate boundaries. We call that type of plate boundary as transform plate boundaries. We have tectonic landforms. We have the faults and faulting as a result of the tectonic framework. And you can see that this part is moving in this direction and this part is moving in this direction. And similarly, we have the, you can see that we have some disconnect here. As a result of that, we might have a small rift zone here. So these are some of the tectonic landforms. Similarly, normal faults are also an important candidate in this subject, and normal faults are those in which hanging wall moves down and footwall moves up. They are normally formed at extensional, where we have more extensional forces, and so mostly the moment is affecting a normal fault. The examples of normal fault is East African Rift Valley and the Rio Grande Rift Valley in New Mexico. You can see here a beautiful example of a normal fault. You see that this part is moving up and then this part is moving down as a result of that, and you can also see some small slips that are also present along the fault, and you can see that there is just like you have buy a big bread and then you make small slices of it, so you can notice small slips here that are a result of this major fault movement. Then we have the reverse fault. In reverse fault, we have the compressive forces that are moving this part over this part, and as a result of that, uh, the part of the earth that is moving up creates a thrust sheet, and those thrust sheets are sometime very extensive. We will have a talk on this tomorrow, so you guys can join and see one of the thrust sheets that are present in Pakistan. We call it as a salt range, and example from the United States are the Appalachian Mountains. Oh, you can see here we have the formation or creation of fault landforms and thrusts or reverse and overthrust faults that are produced by the compression in the crust. And you can see that these two parts are moving towards each other, and as a result this part eventually will move up and creates a thrust sheet. And as you see, this is the process by which most of the landforms that you see while traveling to Islamabad are created. As a result, one block that's broke down as a result of the other and moves above the, the later part. You can also see a beautiful example of a, a wonderful example here of a reverse fault. And in this reverse fault, you see that this bed was continuous once, but now this bed is moving up and this bed is moving down as a result of this movement, and this is probably the fault plane. So you can see that these are some of the tectonic or structural landforms that are a result of the faulting. The Great Rift Valley of East Africa is also a very brilliant example of this, and you can see that this is the maybe the new plate margin where the plate is breaking off. The East Africa is breaking with the rest of the Africa, and it is basically a about 6,000 kilometers long valley, and it has a lot of lakes and have enormous effect on the morphology of the area and the morphotectonics of the area. Then we have the grabens. Uh, Rift valleys are mostly are divided into two parts. We call it host, the parts that are uplifted above, and the parts that are drawn down are called the grabens. And graben is normally a German word for a ditch, and it is basically a depressed block. We call it as a graben. You can also see here there are few small volcanoes that are present here, and then you see the creation of alluvial flats and then the creation of some drainage pattern. So these type of valleys, in short, they influence a lot of geomorphological features. Here you can see a beautiful digital elevation model in which we see the walls of the Rift Valley, and you can see the center with some lacustrine environment. Here's another image of the East African Rift Valley. You can see that the height of these rifts eventually as a result of the movement, and there is some volcanic eruption as well. Oh, as a result of these tectonic landforms, the normal faults are created, and two blocks. If there is one block, it's just like normal fault. But if there is two blocks there and one block is moving down, we call it as graben. And if the central block is moving up, just like this will be host, and then this will be graben. And as a result of that, it creates valleys and it creates depressions, and where water moves from this direction and creates a series of network of various drainage patterns. Then we have folding. Folding also creates mountain ranges and can influence the coastal geography. You can see here folds that are present, and then we have the tectonic landforms. You can see that we have fold belts as a result of the collision between two tectonic plates, and then we have the formation of anticlines and synclines, and these are the like the mountains and valleys and mountains, and similarly some type of tectonic structures. So the fold belts and the tectonic landforms are folds are normally the undulation when the rocks don't break; they just form a series of anticlines and synclines, and they form ridges and valleys that are parallel. Folds may be plunging folds, and they can be non-plunging folds. Some of them they are non-plunging; they just move like this. However, some of them they just die off, and then they go to the lithosphere, and they create a plunging direction. Oh, you can see here some of the morphological shapes. Maybe there has been some recent faulting that has exposed this part above, and similarly in the fields, you can also see that there was some tectonic movement. It was like straight, and then it moves like this because of there has been some fault in it. So in short, these are some of the examples that we have been going through, are examples of the tectonic landforms, and we have been through the volcanic and tectonic landforms in the later part of the class. All right, so if you guys have any questions,